Hi, it's Will and Bree, and we're going to talk some collision theory today.
Collision theory states that atoms, ions, and molecules can form a chemical bond when they collide, provided the particles have enough kinetic energy.
It also states that chemical reactions can only occur between particles when they hit each other colliding.
In order for reactions to take place, an effective collision between the reactant particles is not sufficient but necessary.
The understanding of the exact nature of effective collisions, which determines whether or not particles actually react with each other and form new products, is important.
Will and Bree are going to try and demonstrate some successful reactions for us. The bat represents reaction A and the ball represents reactant B. The reaction will only be successful if the batter hits a dinger. If a home run is not hit, then the reaction is considered a failure. Scenario 1. Strike 1! Failure. Scenario 2. Another failure. Scenario 3. Ouch! Failure. Scenario 4. Success at last. Finally, Will finally hits a home run.
The first three scenarios were failures because the full reaction was not met. The insight gained from these demonstrations is effective collision.
Effective collisions are ones that result in a chemical reaction, and in order to produce such a collision, reactant particles must meet a minimum amount of energy.
Another insight gained from the demonstration was reaction rates. Rates are the measured changes that occur within time intervals. This energy that initiates the reaction is the activation energy. The arrangement of atoms at the peak of the activation energy barrier is called the activation complex. The activation complex is also sometimes referred to as the transition state.
Factors that affect reaction rate include temperature, concentration, surface area, and catalyst.
Rising temps speed up reaction when the motion of particles is more chaotic and energetic than at lower temps. Lowering temps slows down reaction.
The number of reacting particles in a given volume affects the rate at which the reaction occurs. Therefore, increasing the concentration increases the reaction rate.
The smaller the particle size, the larger the surface area for a given mass of particles. Increasing the surface area increases the collision frequency and reaction rate.
A catalyst is a substance that increases the rate of reaction without being used up itself in the reaction. It permits reactions to proceed at a lower energy than is normally required. The lower the activation and energy barrier, the more reactants can form products with a given time. Energy content of reactions undergo activation and is released by reaction. The energy content of products then goes through reaction process.
This is an exothermic graph because the initial reactance is more than the outcome of products. And that is an endothermic graph because the initial reactance is less than that of the products.
Scenario 4. That's inside. Charge some mound, one more of those. Scenario 4. Inside. Scenario 4. That's a foul ball. Scenario 4. Run it. I'm still recording this. Home run! The whole thing.
That was the last sentence, too.